Suppose a city is roughly circular, radius of 8 miles. Go ahead and draw that. Okay, the density of people can be modeled by some function, delta x, delta of x, in people per square mile. So we want to set up an integral to find the total population if x represents the distance in miles from the center of the city. So in the center of the city, we have some certain density of people, and as we get further out, the density of people changes. So the density is going to change in these concentric rings. So let's pick a spot some distance out from the center. So this will be x miles from the center, and we'll give it some thickness, a small thickness, small enough so that the density is going to be pretty much the same over that whole ring. So the thickness there is delta x. So if I wanted to find the total population in this city, I would want to add up the population in each of these concentric rings. So the population in my slice, population of the little slice I drew there, is going to be the density of the slice, because that's people per square mile. And then I want to multiply times the area of that slice. Which is in miles squared. So that my miles will cancel, and I'll just have people left as my units. So delta x is just some function. I just need to know the area of that slice. So what I'm going to do is unroll it. If you unroll that slice, it unrolls into this rectangle with thickness delta x. The length of that rectangle is the circumference of the circle, which is 2 pi x. So the area of the slice is 2 pi x delta x. So this is going to be the density function times the area of the slice, which is 2 pi x delta x. That's the population on a single slice. And then what I want to do is add up all the slices starting from 0 and ending at 8. So my total population is going to be a sum of the population of each ring, which is going to be the density at that location times 2 pi xi delta x. I goes from 1 to infinity, and then take a limit as n goes, I goes from 1 to n, and then take the limit as n goes to infinity. All right, this translates to an integral from 0 to 8 of delta x, density of x, times 2 pi x dx. And then they just asked us to set up this integral. We don't have to evaluate it. And that's good because we can't, because they didn't tell us the function for the density. They just said it's some random function delta of x.